everybody. Welcome back to an episode of The Skeleton Crew. I'm your host, Jen Callahan, and tonight my guest, Eric Moch. He is the CEO and co-founder of a company called Glimpse, and his company is using X-ray and CAT scan to not deal with anything medical related or body related, but they're actually doing it for quality monitoring of batteries. So he's going to share with us what his company does and kind of how he got into this field. So Eric, thanks for taking the time to be with me tonight.
Thanks for having me.
Yeah, my pleasure. And I'm excited to get into this conversation with you because right before we started recording, Eric had shared with me that he actually knows one of my previous guests, Lenart, who he was from, doing something similar to what they were, how they're using X-ray to, make sure that the quality of different cast models were doing well. So it was interesting to know that we shared a common thread there, and I didn't even know it. But Eric, why don't you start with us about Glimpse and, give us a surface of what you guys are doing right now.
Yeah, absolutely. Maybe before I dive in, I thought it might be helpful to explain the audience. I'm guessing not everyone is familiar with the battery industry, so maybe take it from the top. I think when we talk about batteries, there's sort of two types of batteries. There's the battery cells. It's also called primary batteries. And then the battery packs, also called secondary batteries. So battery cell is sort of the smallest unit of energy storage that you can buy. And cells come in typically three form factors. So you have the cylindrical cells. Those are, think of it as AAA batteries on steroids. They're a little beefier, bigger. Then you have the pouch cells. So pouch, think of it as like a thin sheet. And then prismatic. Prismatic look like, big metal bricks, essentially. And so you have those three form factors, and those are cells. And then a battery pack is made out of multiple cells. In a car, you typically have a few hundreds up to a few thousands of those cells. And so just wanted to have the distinction here. Glimpse, our company, focus at the cell level, not at the pack level. There are folks that scan entire packs, but you need much bigger equipment, and I think it's sort of a different use case.
Okay.
So with that being said, yes, we use X-ray CT scanning for essentially harnessing insights from those batteries, gathering insights for our customers. I would say that this is a fairly well-known technique in the industry, but it's been a luxury instrument, right? It's been a very slow, low-volume inspection techniques that typically live in a lab and is operated by scientists. Typically, folks would scan a few cells a day, and then the sort of really deep dive into those into this data set to then generate some conclusions at the lab level, maybe for new designs, failure analysis, etc. But when you look at the battery industry, it's a very high volume industry, right? So a typical factory that produces those battery cells will produce, few hundred thousands per day up to a few millions per day of those battery cells. So you kind of have a discrepancy here where CT scanning is a very valuable technique, very insightful. But on the other end of it, you're trying to apply this technique to a very high volume industry. And so we created Glimpse to sort of resolve that discrepancy and take CT scanning from the lab into the factory floor, on the factory floor. And in order to do so, obviously, you have to scale it by several orders of magnitude. And so that's kind of the mission of Glimpse, is democratize CT scanning so that you can make it a high throughput tool for the battery inspection industry.
Okay. So what types of companies would you be working with who would be scanning their cells?
Yeah, any company out there that deal with batteries. So battery producers and battery buyers typically are the two sort of large group of customers we deal with. So battery producers, the biggest in the world are Panasonic, LG, Samsung. In China, you have a lot of those. The largest in China is CATL. So those produce the battery cells. Okay. And then the buyers are, honestly, so many different industries. Obviously, you have the electric vehicle manufacturers. So think of, BMW, Ford, GM, etc. But you have the power tool industry, obviously use a lot of batteries, right? In a cordless drill, you have many batteries. And so think of Black & Decker, Milwaukee Tool, and then satellites company, small domestic appliances, etc. So these are our two types of customer, the people who produce batteries and the people who buy those batteries.
Okay. So you were talking about the automotive industry, and I thought it was interesting that yourself and one of your co-founders both used to work for a large name. I don't know. Is it okay for me to say it?
Of course, yeah, of course.
You used to work for Tesla, and that's where you met your other co-founder. So how did you guys get to talking and, figure that you kind of wanted to leave that business and, start into your own direction with the batteries?
Yeah. So Peter Achia is our CTO, and Peter and I met while we were at Tesla. And we had somewhat different roles there, but we were obviously working very, very closely on the engineering side of battery cells.
This episode is brought to you by xraytech.org, the RadTech career resource. If you're considering a career in radiology, check out xraytech.org to get honest information on schools, degree options, career paths, and salaries.
And I think it's just a realization that CT scanning is really a super insightful technology. It's used across the sort of development cycle of a battery cell. So all the way from R&D to prototyping to mass production to failure analysis if and when the battery fails. Mm-hmm. And because we realized that it was so useful, we wanted to make it ubiquitous for the industry. And so that's kind of where the idea came up, and we started thinking about, okay, are there any like physical limitation to scaling it? And what are the reasons why it hasn't been scaled so far? And so we decided to start Glimpse to sort of open up that capabilities for the entire industry.
Okay. Do you work with Tesla currently?
We're not at liberty of sharing sort of which customer we work with.
That's fine.
So unfortunately, I'm not able to comment on that.
That's all right. No problem. So I was looking on your site and reading, to see, how you're starting, finishing, and the different, business that you guys are doing. And it was interesting that you'd said, that a battery might be working fine when you first get it, especially in a car, because the site had mentioned, like it could be working for several thousand miles, 100,000 miles, and then all of a sudden it dies because there is a defect within it. So the CAT scanning of it could detect something like that before it's even put into, say, a car?
Yeah, great question. And I think that's somewhat of a subtle point, but a very important one. Essentially, if you think of a battery as a system, it's a very technically nuanced system, and it's almost like a living organism, right? And just like in a human, if you have a stage 1 tumor, you can do a bunch of tests where that tumor is going to feel invisible. You're not going to pick up on any signal, right? If you do a blood pressure or electrocardiogram or sort of heartbeat to measure your heartbeat, you're not gonna see any stage 1 tumor out there. Mm-hmm. But if you do a MRI or a CAT scan, it's gonna be very obvious, right? And so it's this idea that in batteries you have a whole family of defects that we call latent defects, meaning that they haven't materialized yet into a measurable signal. And by signal, I mean electrochemical signal, right? So you apply voltage to the battery and then you read the response. So that defect is going to be invisible. It's going to have zero electrochemical signature, but it's there and it's latent. And if you keep using the battery, and using a battery means charging it, discharging it, right? You drive your car, you charge it, you drive it, you charge it, and you cycle through the battery charge and discharge. Eventually that stage 1 tumor is going to develop into a stage 4 tumor and is going to create real issues. And by the time you can actually read that issue from a electrochemical standpoint, it's too late. You have to change your entire battery. So that's why CT is so relevant, because you can catch those defects before they actually become perceptible.
Okay. So the CT, I mean, just thinking of it from a medical standpoint, it's cross-sectional anatomy that they're looking at. I'm assuming that the CT scans for the batteries are the same way. You're doing like coronal and sagittal sections. I mean, you might possibly be using different words. I'm not really sure.
Yeah, I guess we came up with what we thought was the most obvious orientation, but you're absolutely right. We're essentially slicing the batteries multiple directions. There's sort of different orientation depending on the geometry of the battery. So if it's a cylinder versus a rectangle, we slice it in different ways. But basically, we want to capture as much of the information as possible. while sort of minimizing the data size. So we try and slice it intelligently so that the user gets as much information as they need while not carrying, hundreds of gigabytes of data around.
Okay. So these defects that are detected, I'm assuming it probably comes off in some type of number form, but are there images that are related to it that you can see that, is there like a crack inside of the battery or what?
Yeah,
How
there's
can you tell?
for sure. So that family of sort of latent defects come in different sort of shape and sizes. Cracks, tears, um, sort of bumps or like pinholes. What else? Wrinkles. So batteries are made out of electrodes. Sometimes those electrodes will sort of fold on themselves or have wrinkles. Foreign particles. So yeah, different sort of typology of defects, but most of them, if not all of them, are observable by CT.
Okay, cool. Um, so you guys have started in this, and what's the development in the manufacturing about batteries that you feel, might be moving forward that might make batteries possibly better?
Yeah, I think I mean, this is a self-serving response, but I think better quality control will, I think, help the industry overall. So that's kind of the mission that we have at Glimpse. More generally speaking, I think there are different chemistries that are being developed or even industrialized that I'm excited about. So we talk a lot about lithium ion, right? There's another chemistry that has been developed over the past few years called sodium ions. So essentially, you replace lithium by sodium. This is a bunch of different changes in your sort of battery cell design, but it's got different trade-offs. So one is good for high energy density and a long lifetime. The other is good for sort of lower energy density but lower cost. So it depends on your application, but I think people are developing those new recipes, and we can really hone in on a given application. And by application, I mean energy storage application. So for instance, an EV is going to have different energy density and power requirements than a grid battery that sort of pairs with the solar panels, where you want to store the energy that's harnessed from the sun, and you want to distribute it at night, for instance. Those have different needs, and so you can sort of tune the chemistry for those different use cases. And I'm very excited about that because it sort of shows that the industry is maturing for various applications.
Okay. And then the CAT scan can be used, for these future development of batteries that's going on.
Absolutely, yeah. We've sort of proven for ourselves because obviously with CT a lot of times there's only one way to find out. You got to scan the object and confirm. But yes, we are sort of chemistry agnostic, and we can produce the same level of image quality and generate the same level of insights, regardless of which chemistry you're talking about.
Mm-hmm. So again, I was, always doing some reading before I meet with a guest, and Eric and I were discussing, some of the other people that are on his team, and although this isn't technically radiology related, what they're doing, they do have someone on their team who was part of imaging science, and worked in AI for, one of the larger companies out there, for imaging. How do you guys utilize, the AI portion of his background?
Yeah. So yeah, I think you're talking about Jim. Jim has an extensive career. He worked at CareStream before, which is a CT company for the medical application, right?
Right.
And I think that we have a lot to learn from the medical industry. I think medical industry has pushed the sort of full suite of hardware and software technologies pretty far. The considerations are a little different, right? Because when you scan a human body, you want to sort of maximize your signal while minimizing your dose of X-ray, right? Sure. You care less about scan time in the sort of battery industry, at least. What you care about is throughput. So you want to scan as many parts per minute as possible. And so you care much less about the total dose that's going to go through your battery, because X-ray up to a certain energy level will not alter your battery. But what you care about is really going through as many products as possible. And so you can really go hard on sort of the X-ray dose. So those learnings will have to be translated and sort of refactored. But I think Jim is bringing a lot of those learnings And yes, he has extensive experience in computer vision, and he's sort of helping us build our technology from that standpoint.
Okay. It's interesting how, you would think that two fields kind of aren't related, but they are.
Yeah, a lot of the building blocks are, and again, there's slightly different equations to solve between those two fields. But if you solve that equation in the prior field, you can, and you understand how you did that, then you can sort of apply the same recipes and then apply your knowledge to the next industry, which is what Jim is doing, and it's been really, really helpful for the team for sure.
Yeah. I mean, I'm sure he's helping you overcome some different challenges. What challenges in general have you guys met since the start of the company?
Oof, that's a good question. What challenges haven't we met? I think no. Honestly, it's been really well. I think the typical startup challenges. How do we scale? How do we make the right decisions? I think especially over the past couple of years, startups have had to shift from growing as quickly as possible to actually generating revenue as quickly as possible and even turning a profit, or be at least proving that they can turn a profit. So typical challenges of startups: how do we go to market as quickly as possible? How do we generate revenue as quickly as possible? So that's been one. On the technical side, I think so. We're mostly a software company, right? We partner very closely with hardware vendors, so CT vendors. We are not building CT ourselves. We are partnering with the hardware vendors. And so I think one of the challenge was finding out who are the best players to partner with, and who are the what is the best portfolio of hardware that we want to integrate our software onto. So that's been an interesting challenge, and I think we feel pretty good about where we are today. But obviously, it's going to be continuing because we're not producing our own hardware. It's going to be a constant question of who are the right partners and what are the right technological choices that they need to make to sort of work with us.
Right. I think that's a challenge, in all fields that are using, different technology. Even I'm in a hospital and we're putting in a new room, and, they're trying to figure out who is the best vendor to get the new machine from. So, I mean, that same challenge that you have, I feel like is met across the board in a lot of different areas.
Yeah, that makes sense.
So for people who are moving forward in the battery manufacturing, and from the different scans that you've done, I mean, what would be your suggestion for them to help for the, better quality monitoring, or to, I guess, not to say fix it before it happens, but, maybe a different quality control within the factory? Have you ever thought about that?
Yeah. So I think for folks who are joining the battery industry, if I understand your question correctly, so sort of battery engineers that will, consume CT data one way or another. I think I'm trying to give tips that are not too self-serving, but obviously, we're very biased here. But I think realizing that CT is a very powerful tool, but if you use it well, you can generate a lot of data per unit of time, say per day or per weeks or per month, and then sort of data management become a bottleneck, right? And if you're a battery engineer, it's not the case for every battery engineer, but it most likely you're not a data scientist, or you're not a data engineer, right? And so how do you do your job without being overwhelmed by the amount of data that a technology as powerful as CT generate, right? And obviously, Glimpse is doing a lot of work there so that battery engineer can focus on building better batteries without actually having to deal with, hundreds of gigabytes files per day or every day. So that's one thing, is sort of making sure you partner with the right company so that data is not a bottleneck to your work. And then I don't know if I'm answering your question directly, but another thing that we've seen in the industry, so in the battery industry, I think CT scanning, again, there's a consensus that it's a powerful technology, but we see a lot of folks making mistakes when they select the equipment. So kind of going back to the point you made, or the reflection that you had, buying the wrong piece of equipment, because I think a lot of CT vendors are really good at marketing, and they all are seeing this battery market as a very exciting, huge, growing market, and so they obviously want a part of it. But if you're purchasing or sourcing a piece of equipment like this, you need to put a lot of thoughts into what are you trying to do with it. And I think that's what we did at Glimpse. So I would say, open invitation, come talk to us. We're not, this is not just necessarily sell you something. This is actually to help you if you're purchasing the equipment, whether you're actually going to use our solution on top of it or not. Talk to us. We've visited a lot of different vendors, and we understand what makes a good CT scanner, what makes a bad CT scanner, specifically for the battery industry. And we're happy to share those insights with you, because it's in our best interest that the industry choose the right set of equipment. So yeah.
Have you guys, since you've been open and doing the scanning for the different types of batteries, have you had like a significant moment where that you've made like a difference, like that you've had a customer come and say like, wow, like the feedback that we got from you from the different scans like really made a difference, and we're going to go back and look at maybe it's the way that we produce the batteries, or something like that ever happened, like almost like an aha moment, like for them, really, not for you.
Yeah, no, absolutely. Yes, and we're very proud of that. So we just launched our product about two months ago, and we've been lucky to acquire a number of customers since then, and some are very large customers, and we're obviously very proud of working with those large customers, because these are renowned and well-respected companies. But I think personally, my proudest moments when we're working with startups that cannot afford to put $500,000 into a piece of equipment, right? And $500,000 is sort of the low end, right? It can go up to $1 million, $1.5 million, and they're just not there yet in their journey, but they still need to check on their progress, right? Is the battery that I'm designing is well built? Does it have defects? Is it going to behave well? What's the lifetime of that battery? And then how the battery degrades over life as I'm charging and discharging it. And really, in order for them to acquire those insights, they either have to purchase an equipment, and it's not just purchasing it, but it's staffing it and then, running it, etc. Or they have to spend a significant amount of money for a couple scans here and there. And so what we've labeled with at Glimpse is really a low cost, high image quality, high resolution CT scanning on demand service. So you send us the batteries, we'll scan them for you, and then we'll send them back. And instead of sending us 1 or 2 battery cells at a time, they send us, tens, 50, hundreds of batteries at a time. And so suddenly they have access to all this information, and obviously we package it in a way that is very user friendly. And without mentioning names, there's a few startups out there, you could tell they learned something they didn't know, and they got sort of some information about things they need to care about, they didn't care about before. And I think I was super proud, because in a way we're sort of doing our job in helping the entire battery industry in the US to sort of mature, and I think it's super cool.
I mean, from a person who uses batteries, I'm sure just like you do, I mean, I have kids at home, and, we're always changing batteries and stuff. There's nothing more frustrating, when your batteries die, you're like, oh, I just changed this. Like, I don't know if that's a quality issue, from something that we're discussing, but I mean, it's frustrating, and batteries in general, and I'm just talking about like household batteries, are expensive. Yeah. So,
yeah,
I mean, we want to make sure that what we're buying is of quality.
Yeah.
I did want to go back to how you said, how many they send you to be checked on. The people who are asking, to send their batteries to you to be checked, do they send them in like batches from like, say, like, they just produce, say, like 500 batteries at once? Do they take like a small portion of that, maybe say like you said, like 50, they take a portion of that 50 and they send them to you for them to be checked?
Yeah, great question. So the answer is yes, but not only. So there's many different use cases that we see from our customers. Some of them, just like you said, they have a small pilot line, and they're producing sort of batches in small quantity. The 500 cells is a small quantity in the battery world, right? And they want to make sure that their production run or their pilot run went well, and that they're built according to specs, right? And so they use our services, and they can access that data very quickly. Other folks are sourcing batteries because they're building, I don't know, electric bikes, or, new types of scooter, or you name it. And they want to make sure that the quality they're getting from their suppliers is good, right? Or maybe they're trying to down select between 3 suppliers, and so they get 3 batches of batteries, and they want to make sure that sort of build quality is one criteria that they use to select their supplier. And so they send us those 3 batches, we scan them, they can look at them, and they can sort of quantify which supplier is good, which supplier is bad, right? So that's another use case. And then another interesting use case that we found is, I don't know if you're familiar, but there's a whole industry of battery raw materials. So it's sort of the raw materials that goes into making a battery cell. So typically those materials are anode, cathode, electrolytes, and those companies that are coming up with these sort of breakthrough innovations, they're producing a liquid, a powder typically, and they want to make sure that they can showcase their product. And so the way they do this is they use what's called a toll manufacturer or a third-party manufacturer that will take their powder or they would take their liquid and they would build battery cells with them. And then these companies, they're going to take those battery cells and then try and send them to their customer and say, hey, look how our material is doing in a full system in a battery cell, right? But as you're outsourcing this sort of cell building process, you're kind of losing control in the build quality. So before those raw material companies send the cells to their customer for testing, they go through us to make sure that the build quality is good enough, because you don't want to you don't want to send defective product to your potential customer, right? And so that's another use case that we're enabling. And there's a couple others, but sort of, you get an overview.
Do they share with the potential customers that they have gone through Glimpse and have had their batteries tested or the battery cells tested?
Yeah, great question. It's actually interesting because the way we supply the data to our customers is through a secure web application. So it's something that, you can sign up and you can sort of consume those scans online. And so we can add as many users as possible as our customer want. And also our customer can request us to add their customer to the same space. And so imagine you're sort of startup XYZ doing a new raw material, and then you're sending cells to your customer, and you're asking your customer to test it. And as you're doing this, you're saying, hey, you can actually look on the Glimpse portal that this battery is well built. And so we can sort of add as many people as we want, as long as they're authorized to view the data on that same portal. So more people can access that data set.
That's awesome. So it's the proof is there, you just don't have to take my word for it.
Exactly.
So this is all great that, your company's here, that you're scanning as many batteries as possible. They can send them, your customers can send them in batches or smaller batches. But what if they wanted to not send you your batteries? Is there another avenue for them to be checked? Do you guys go out to their facilities, or what would be another avenue for them to have them checked?
Yeah, absolutely. So we essentially have 2 models, actually. So the first one we discussed, which is, we call that a scan on demand. So, you wake up on a Monday, you want to send us 30 batteries, 300 batteries, you send them to us, we'll scan them and then send them back. The second model is what we call on-premise scanning. So essentially, because, shipping batteries across the country is not a very scalable thing to do, and it, has cost and sort of turnaround time associated to it. For larger customer, what we offer is to actually deploy our software solution onto their scanner. So some battery producer or battery buyers already have a scanner. Mm-hmm. Some are looking to acquire a scanner. And so if they want to turn their scanner from a lab instrument into a high throughput sort of battery quality monitoring tool, they would come to us, and then we would deploy our software solution. We literally layer our software solution onto their scanner. And then suddenly, instead of having those large data files and opening up the data locally on a desktop, everything become web-based, and they can have as many users as they want. And then our platform can host as many scans as they want. So as they evolved year over year, sort of built this database of battery quality, and they can compare the past versus the future, or different batches or different factories. If you're a large customer, you have multiple factories. So this is the second model that we've been working on, and very excited as well, because it really, it's kind of one order of magnitude higher in terms of scale, right? You can scan so many more batteries, and then the dollar per scan goes down, right, for our customers, because they get to operate the scanner. They don't have to ship batteries around. They can really scan as many batteries as they want. So yeah.
That's nice. to have it on site. But speaking of that, do you go out and have to do quality control for the scanners that you provide them? Do you have to go out and check them like, once every 6 months or once every year just to make sure that it's functioning,
Yeah, we offer there's a service or a maintenance that comes with service. But again, we're mostly a software company. So the person who's going to check if your scanner is on spec or if it's working well is actually the scanner vendor.
Okay.
That's the company we partner with, right? The service that we offer is more related to the software we provide and also sort of the data processing. So something I haven't mentioned is there's a lot of heavy lifting sort of data processing that happens locally next to the scanner. And so when we deploy our solution, we actually deploy a computing station. So think of it as like a gaming station that's going to take the data from the scanner and then process it locally and then send it to this secure web application. Mm-hmm. So that's what we offer service on. But the CT scanner is actually our hardware vendors, partners that do that.
All right. That's a good, transition from, doing it in-house to, outsourcing it. So going from that, where do you guys see Glimpse moving in towards, for future developments or anything that you're hoping to, hone down on in terms of quality monitoring?
Yeah, I think a big area of development for us is driving down scan time, right? For a given level of image quality, because you can always trade image quality for scan time, right? If you run your scanner faster, then your image quality is going to get worse. So what we're trying to do is reduce the time it takes to scan a battery while maintaining a certain level of image quality so you can still extract value from these scans, from these images. And the way we have achieved that, and we're going to continue achieving this, is really working across the entire stack. And by stack, I mean the technological stack. So, hardware, what are the components? What is the X-ray source? What is the X-ray detector that gets you the highest throughput? And then how you operate that scanner. So as you might be familiar with, there are so many parameters when you operate a scanner that you can tune, right? And a lot of them have trade-offs. So you can trade, contrast for noise, or you can trade resolution for sharpness, etc. And so how you operate that scanner is another lever that we pull and that we do a lot of optimization on. And then lastly, how do you process that data? And I'll give you a couple of examples. If you can make that data cleaner and crisper at the end of it, then you can deal with worse data at the beginning of it. And if you can deal with worse data, then essentially you can run your scanner faster, right? And so pulling on all those levers is really an optimization across the technological stack that enables us to drive down scan time. And so we're working with, on the hardware side, we're working with very forward-looking CT vendors that are working on integrating new components, like I said, X-ray source, detector, to produce the same level of image quality faster. But then we have, as a software company, we have to do our part in making sure that we can process this data, because essentially there's more data now, right, per unit of time. So process this data and still provide a good user experience for our customer. So that's a big area for us. And then just sort of honing in on our two business model, scan on demand, on-premise scanning, and trying to serve as many customers as possible.
Do you have a good amount of customers that have been interested with the on-premise scanning?
Yeah. We're working on our first deployment, so we're very excited about this. And there's going to be some announcement later this year, talking with a number of customers. And these are larger companies. Obviously, they typically already have a scanner. They want to sort of 10x it in terms of what we can do with it. And so very exciting avenue. You really can feel that you're creating value there. So yeah.
Awesome. Well, everybody, this is Eric Moch with me tonight, sharing with us a different way to use CT scanning, not so much for bones and abdomens and things like that, your batteries that you're using either in your car or in your household appliances, are actually being quality checked. So don't think that they're not. Eric, thanks for being with me tonight.
Thanks, Jan. It's been a pleasure.
All right, everybody. We'll see you next week. Make sure that you check us out on YouTube and Spotify or Apple Podcasts. You've been watching The Skeleton Crew, brought to you by xraytech.org. On the next episode, join us to explore the present and the future of the rad tech career in the field of radiology.